Hello everyone. So today we are starting with chapter 11 from PUC first year computer science, arrays. So let us explore this chapter. See, array is a facility where it is used for storing group of values of similar data type. Right. So that means usually when I write variables with int A is capable of holding only one value. You can't store multiple values into the variable k. We don't have a facility of writing like this. We can write only one value. So this is valid one. This is invalid. This is not possible in C++. So array is such a feature where group of values can be stored into a single variable. Right. First point. Second point, all values what you want to store into the array, they should be of same data type. Third point, all array values stored in the array are all identified by single name. Third point. Fourth point is array elements will be having their own serial numbers called index. With the help of index, we access these elements. These index values for array elements will start from 0 and ends at total number of elements minus 1. Right. This is how array will be like. See, let us see one diagrammatical representation. Down it is there. We'll see. See, this is like this. And one more point about the array is what? All the values of the array are stored into the contiguous location or linear locations, right? Kindly remember these points. Array holds group of values. Second point, all array elements should be of same type. Third one, all array elements are stored in a contiguous memory location. All array elements are identified by one name. Fifth point, every element will be provided with some sort of serial number. That serial number is called as index, where this index starts from 0 and the index ends at total number of elements minus 1. It's 5 points you remember. Let us go with how to see. There are three different types of array: one-dimensional, two-dimensional, and multi-dimensional array is there. Where in the one-dimensional array, right? So here I'll show you diagrammatically. One-dimensional array means it will be like this, where you can see that in this one, there is a one row. How many columns? 5 columns are there. Fine. Row is one. Number of columns are more than one. Similarly, in this array, you can see that we have like this, where in this it is 4 rows, 1 column. That means either in the order of the matrix, either the row or column will be 1, another one will be more than 1. You can see here row is 1, but columns are more than 1. Here rows are more than 1, but column is 1. This is called as single dimensional array. This is called as what? Single dimensional array. Right. Now similarly, if we go for two-dimensional array, where multiple rows and multiple number of columns will be there, like a table, right? Like this it is going to be, right? Where now you can see that the order of the matrix is 3 rows, 4 columns, right? 3 by 4. More than one row, more than one column. So this is what? Two-dimensional array. Two-dimensional array. Fine. And there is one more thing called as multi-dimensional array, right? So where in that rows, columns, and levels, three things will be there in that. That is multi-dimensional array. So here you see it is an array in which each element is accessed by using only one subscript, right? So the number of element that can be stored in the array is called as size of the array. How to declare? You have to write the data type, then array name. In the square bracket, you have to specify the size. For example, int marks of 50 means array marks is an array of type integer with size 50, indicating that you can store 50 different integers in this array. So initialization of one dimensional array, right? So initialization means what? Providing meaningful initial value. There are different methods for that. The one you can see here, int e of 5, and the 5 values are given in the opening brace and the closing brace. Values are separated by comma, ends with the semicolon, and values are stored like this, right? So the value 9 is present at, you should say like this. 9 is present at a of 0, right? A of 0. And the 6 value is present at a of 2, like this you have to read, okay? And even similarly for the floating point array also we can assign where we can have real numbers like this. And like this also we can assign. And one more way is instead of say assume that you are giving how many values, right? Totally 5 values you are providing the initialization stage, but size you haven't mentioned it. It will take itself by counting this number of elements. Accessing means what? Values are there in the array, but how to access them and how to use them. Now, for example, assume that in the following array, right? In this array, here, this array, you can see that there are different values stored over here. Suppose if I say a of 0 plus a of 2 plus a of 4. If I say like this, a of 0 means a is the array name, 0, 2, 4 are indices. First element starts with always 0 and number continuation will be there. So based on that, a of 0 means 9 plus minus 5 is there, minus 5, and then plus, sorry, it is a of 2 they have said, that means 6 will come because 0, 1, 2, right? And then a of 4 they have said, that means 8, these brackets are not required. This is the way of accessing the element. When you want to use them, you have to specify the array name, in the bracket you have to specify the size. That is accessing element. And then here, see what we do, I'll show you practically. See here, I'm going to declare one array int a of say 50, right? And here there is a small code snippet which will help you to read elements for array 5 size. And after that, to print the element, we have one more part, which are the two common parts, which will be there in all the programs. Right. So here in this case, enter the elements and see I is started with the 0 because index starts with the 0 and I less than 5. Seen a of I. Okay. And I is equal to 0. Here I need to be declared, or here you directly you can write int I. Int I. And for seen a of I, in the first round it will be a of 0, next round it will be a of 1, next round it will be a of 2. Until condition gets false, it will be okay. And to print the array elements, cout, same for loop. Instead of cin, we have to write cout. Then set w they have written so that for every 5 space, one number will be printed. So when I run this program, you have to enter 5 elements. enter the elements. Extended character. Okay, these quotations are not allowed. Rewrite them. So we have to rewrite quotations. Let's now run the program. So to use setW, we need to have hash include io_manip.h. Enter the elements. Any 5 numbers you enter, positive number, negative number, anything. Those elements will be printed here. Fine. So here there is a complete program for reading and printing the elements. For majority of the program, reading the element up to this section, it will be remain same. See, we want to calculate sum. So what they have done is first reading elements, it is up to that it's same. Sum equal to 0, extra variable is taken, and here it is already declared. Float average after float space is required. Sum is equal to sum plus a of I. That is array element will be added to the sum. And then average is equal to float sum divided by n. Sum divided by n. So sum will be divided by n. The result will be explicitly converted to floating point, then assigned to average, and it is printed on the screen. Similarly, here the program is to find the second largest of n numbers in the array. Right. One moment. Okay. So let us have some simple programs in this. Say I want to calculate the sum of elements. So I'll make it as sum equal to 0. Right. And you can calculate it in this loop only. See, I have placed the block. And here I'll write if a of I, if is not required, simple sum equal to sum plus a of I. Fine. Once after calculating sum, outside the loop, what I do, I'll print that sum equal to sum. Now, when we run this program, you can see that enter the elements as already we are given size as 5 only. It is mandatory that you have to enter 5 elements only. See, so I'm entering some elements. So after that, it will calculate the sum of all that and it prints sum as 35. Even this program can be a little customized. I'll make it 50 and I'll take a variable n, right? So what I do, cout, will say enter the size of array. Cin, it is n. Now enter the elements. This 5 I'll remove it and I'll place it as n. But remember, the maximum size you are given it as 50. See to that n you don't give it as don't give more than 50 or more than 50. Should be always less than 50. Right. So that now what happens? It'll ask you enter the size of the array. I want to enter only 3 elements. Fine. So enter 3 number. You will get sum of 3 number. When you run the program again, so you enter say 7 number. Now you enter any 7 numbers and your program will work and it gives the result. So you have a choice of entering the size of the array. Fine. So say assume that I want to calculate only the sum of even elements. That means the element what you are entering in that which are even, no, only that sum I want to calculate. So before I add a of I to the sum, I'll check if a of I modulus 2 is equal to 0. Earlier in the looping statement, you used to say I modulus 2, but now what do you have to do? You have to say a of I because a of I represents array element. A is array name and I is representing the index, right? So now it will calculate the sum of even elements. Suppose I am entering 4. Now you see I'll enter even number as 2 and 4. Remaining 2 numbers I'll enter it as odd. So our answer is 6. 2 plus 4 is 6. Only sum of even array element. And similarly, if you make this as 1, you will get sum of odd arrays, right? Say, assume that we want to find out the biggest number, say max I'll take, right? Sum I'll cancel. So before that max, I want to show you average, float average. It is there in your practical program. So once after calculating sum, what we do? Average is equal to sum divided by n. N is representing total number of columns. As sum and n are integers, so the result AVG is a floating point variable now. So it has to be converted to float explicitly and then print average. Average. Run the program. I'll enter say 5 numbers. Enter any 5 numbers. You can see that average is 3.2. Okay. And now let us go for finding max, that is maximum element of the array. So for that, what we do, we can't do it in the reading part only. Better we'll separate that section. Here what I do, max equal to a of 0. The first element I'll put it in a max variable. And then I'll make the comparison from the element 1 with the value present in the max variable. So I start index from 1. And here if a of I, that is the element, current element, if it is greater than max, then in the max it should get value of a of I. The current value is assigned to max. That procedure will be repeated until it reaches end of the array. And in max variable, you will be having maximum element is max. Now let's execute 5 elements, enter any 5 elements. So the maximum element is 9. You can see that. So we have entered 5 elements here, 6, 9, 8, 7, 5. The maximum element is 9, right? This is finding out the maximum element. And here in your textbook, they have given program to find second largest number, right? For that, what they have done, they have declared the variables. They have taken largest variable name. Then second largest is there. First, how many elements you want to enter, that you have to feed in n, and that much number of elements will be read. And then if a of 0 is greater than a of 1, right? So in such case, largest is a of 0 and smallest is second largest is a of 1. Else, a of 1 will be the largest and a of 0 will be the second largest. So I'm starting comparison from 2, where a of I means current element, that is a of 2. If it is greater than the present largest, right, then a of I will become largest and the largest will become second largest, right? So that means it is working like this. See, it is working like this. Say, suppose if there are 5 elements like this. First, in the largest variable, they are storing 9, first number. Second largest, they are storing 5. Then they are comparing. A of 0 is greater than A of 1. No, first they are comparing. A of 0 is greater than A of 1. See, this is A of 0, A of 1, A of 2, A of 3, A of 4. Right. A of 0 is greater than A of 1. That means 9 is greater than 5. Yes, it is true. So when it is true, 9 will come in largest and 5 will come in second largest. After that, you see, suppose if the condition is false, these values will be reversed. Then second, in the for loop, what they are doing is I is equal to 2 from the second element they are starting. That means from this element. This will be the current element. So wherever they write now first A of I, no, it represents this. In the second, in the for loop, they are saying if A of I is greater than largest. So what happens? A of I means A of 2, that is 6. 6 is greater than the number presented largest, false. When it is false, so what happens now? In such case, largest will be remain 9 only. In the second largest, we are going to check. We are going to check one more condition. If it is true, largest comes into second largest and the current element is assigned to largest. So else, if E of I greater than second largest, E of I means what? The current element. If it is greater than the second largest, then this will be assigned to the second largest. So to understand this logic, it is better to do a tracing, right? So that we can understand it better. Okay. So here what we do, will have I, E of I, largest, second largest, right? So I is starting from 2. Here already we have 9 and 5 because of the previous comparison. E of 2 means what? E of I means I is 2. E of 2 means 6. E of I is greater than E of I is greater than largest. This is the condition. If so, E of I should be assigned to largest. We have to. E of I is having 6, largest is having 9. So condition is false. So it goes to else. E of I means 6 greater than second largest. Yes, 6 is greater than 5. In such case, assign E of I to the second largest variable. That means in the second largest, we are going to get 6. 5 is the rest. And I plus plus means I will be 3. I less than n condition is true. And after that, if E of I E of I means what? E of 3, that is 7. 7 is greater than largest, that is 9. That is false. So E of I is greater than second largest. This condition. E of I means 7. Second largest means 6. 7 is greater than 6. It is true. So that means what? This will become 7. After that, again I plus plus 4. And then when it is 4th, condition is true. E of I means E of 4, that is 8. Is greater than largest. No, it's not larger. So now if E of I is greater than largest is false. That is this one. 8 greater than 9 is false. When it is false, it goes to else part and checks this if condition. If E of I is greater than second array, second largest. If E of I means how much? E of 4. E of 4 is how much? This 8. If it is greater than the second large, yes, then E of I is assigned to second large. That means the 7 will go off and the 8 will come on the screen. So now what happens? I will be plus plus 5. Condition is false. It will come out from the loop and print largest and second largest number. It will be assigned to the respective variables. And now, similarly, one more program. Say here to find the position of an element in the element in the array using linear search method. We have to search for the array and we have to check the searching element. So for that, you have then position I element and n is stored. Asking for the size of the array, and then we are taking input of elements, and here in this right. Yes. Now if position is greater than 0, it is present at position. Otherwise, it is not present at the required position. Right. Now, similarly, to sort the array elements, whenever you want to sort the elements, no, then how to do it? Up to array reading element, it is same. For I is equal to 1, j is equal to 0. And then for j is equal to 0, j less than n minus I. And then if the condition is true, our values will be rearranged and then it's being printed here. The next is memory representation of a one-dimensional array, how it is going to look like. See, it depends on the data type of what you use, whether you are using in the float, character, or integer array or structural array. Based on that, the memory approximation or calculation will be done. Now you can see that all the elements are stored in contiguous memory location. Right. Now, here you can see that 5000 is the memory address of the first element. Then 5001, 5002, 3 and 4, right? Up to 5 elements, they have provided the space. And even it is possible that the element E of 0 is allocated a particular memory location. The element 1 is corrected, a sort function. For two, because one integer element consumes at least 2 bytes of memory. So that 2 bytes are given for 2 memory addresses. Correct. And with the size of function, you can find out the memory size of any yes. So this will calculate totally how many bytes required. So the array size 1 into 5 is 5 bytes. And then two-dimensional array. Right. One moment.